I'm going to give one more example that I'm doing. And I will, the last graph I put on the bottom. So you'll notice that what I'm using here is with solutions. There is another piece of code that is exactly the same that says no solutions here. There's the last graph I'm going to give you if you'd like. You're also welcome to, after this last example, you're welcome to go and leave, but I will be here. I give basically an exercise at the bottom that will allow you, and I'll sit here and give you time to build it and ask questions if you'd like. But I have one more example before we go to that. But if you don't want the answers, use the code with no solutions. That's why I brought it up. So finally, in this case, I want to look at the relationship between prescribing rates and the overdose rates. So I have a data set that we loaded in. So let's look at the state.prescribe. Our data set that we're using for this one is at a state level. It has each row is a state, prescribing rate, an overdose rate, and a specific year. In this case, we're again going to take the most recent year. So we will take that and subset it to 2017. We have our ggplot function again. And in this case, we do just like we did before. We have our data frame object here that we're using for graphing. Our aesthetic, X equals the prescribing rate. So our horizontal axis is the prescribing rate, and our Y-axis is the overdose rate. So GM point, the size is equal. We want to set the point size equal to 1. And I want the color or our points to be black in this case, because they'll be more easily visible. So once I run that, this creates our bones, as we said before. So now we have our overdose rate here, our prescribing rate here. Still have that ugly gray background, just as we have in the past. So we will have to customize this as we did before. And I'm going to show you some different things on this that I didn't show in the last two graphs. This is definitely more, it has a lot more of the customizations in it that you can use in any type of graph, but in particular, this is useful. So GM smooth, a lot of times when we create a scatter plot, we want to show what the relationship looks like between the overdose rate and the prescribing rate. We are actually covering linear regression models in the class, next statistics class that we're doing. I believe it's not this week, but it might be the next. You would have to look at my schedule on my website. But we are actually covering this very soon. I'm not going to go into it more than just saying that this shows the relationship between our overdose rate and our prescribing rate. So if we run that, this is what it's going to look like. So in this case, we are seeing that as the overdose rate goes down, in general, the prescribing rate is also going, yeah. So as one is going down, the other is going down as well, I believe. Yeah. Yes. No, I apologize. So as the overdose rate is going down, the prescribing rate is going up. So that makes somewhat of sense based on if the prescribing rate is higher, the overdose rate is going to be lower. So we have a negative relationship here. So we are seeing that negative relationship. So as prescribing rates go up, our overdose rates go down. But we're not seeing that this is a very steep relationship. So this, you would expect the line to look maybe more downward. There's two reasons why I think that we don't in this case. One, what this is showing here around this line, there's a very large standard error here. What that means is that there's a lot of spread in our data, or our points are very spread out. So that's one. So there's a lot of differences between our states. Also, if you look at the county prescribing rates, for instance, within a state, our values vary quite a lot. So the reason I had to use state level data here is because there are no overdose rates available at a county level. Only prescribing rates are available at a county level. So I had to use the state was the smallest unit that I could do, just because that data is de-identified and they don't want to give away any information. So that county level data is for the most part censored, so we can't use it. The last thing that I would say is very relevant here is the overdose rates depend on a lot more than the prescribing rates. There's a lot more elements at play here. In general, as I worked in health policy for a while, there are a lot of factors that contribute to things like this. So in order to get something that looked more significant or would be steeper, we would probably have to add more variables to our linear model and control for more variables. So to give you more background, that's why we're not seeing a huge relationship here. So I want to get rid of these confidence bands here. They aren't adding a lot to this this graph, and I don't want to make it too confusing. We already saw what they were. In this case, I don't want them. So I'm going to show you how to remove them. And then I'm going to change our theme like we did before to theme minimal. So we have our scatter plot. We had our geom smooth, so we set the method to linear model. To get rid of the bands, you put standard error equals false. And in this case, I changed the color of the, before up here, I had not had the color equals blue. In this case, I wanted to set that color equals to blue. And then we have our theme minimal here. So we, in this case, got rid of the confidence bands, changed our color, and changed our theme. So now we have our overdose rate, our prescribing rate, and we have no confidence bands, and there's a lot less information on here. We'll see, you see here that we're using color instead of fill. You could also, as we did above, add a grouping variable here. So say we wanted to add some value and group these and make these scatter plot points different for one group versus another. You could add the color equals and whatever grouping variable you wanted. So we have this. Just as before, we're going to add the labels. So this we are putting as our title. Remember, this is to break it onto 2 lines. And we have our X horizontal axis and our Y horizontal axis. So we're seeing here, although written very small, our average state opioid prescribing rates by overdose rates. And that isn't a great title. It generally is versus in this case, so I can change that. I also think I want to, looking at this, put this on 2 lines. So there's too much on the y-axis line. So in this case, I'm going to create that. And down here looks okay. So looking at that graph, I'm going to make those adjustments. So run current chunk. So we now have on 2 lines here and 1 line there, and we have our labels. So now, just as we did before, it's again going to look very similar across graphs. We added our plot title with a size, centering, face equals bold, our axis title with setting as text, and I saw our size there, our axis text with our size here. Because we don't have a grouping variable here, we don't have a legend. So I run that, and this is what we get. I do need to add in, I had changed the one above it, so we want to add in our putting it on 2 lines. So that's more legible. And we have these. These are still gray, and so that is something we would actually want to change up here as well. So this is how you would actually build it in practice. As you see things that you don't like, you just add in a change one by one. So color equals black. So run current chunk. Now we have a new with black labels here. So as you see here, the x-axis is getting cut off. In order to change these axes, you can manually change these or change the minimum and maximum. So in this case, I'm going to set both of those. I'm setting our limits to equal 25. So it's going to cut off at 25 here and 115 here. You'll notice here that I'm setting the x-axis. So if you wanted to change the y-axis, it would be scale y continuous. In this case, we're setting the minimum to 25, the maximum to 115, so it will allow more space on the other side of this 110. And we are manually going to set the breaks as exactly what labels we want here as 40, 60, 80, and 100. So if we run that, that's the only change I made. Now and we had changed color. You would usually not do this one by one. You wouldn't create separate graphs, but in this case, I'm trying to demonstrate exactly what you need to do step by step. So we now have our average opioid prescribing rates. We have our new breaks. So it goes from 40, 60, 80 to 100. We're not getting cut off here anymore. Say accidentally I cut off my values at 100. It would actually throw a warning variable saying that you are missing or cutting off 2 points. So just FYI, if you do make that mistake, it will let you know. So somebody at the beginning of class asked, how do you label things? How do you add labels? So you can do this for any, like for your bar graphs or anything. It's going to look very similar. In this case, if we labeled everything, it would be a little overwhelming. There's a lot of points up here, but the ones that are most extreme, the ones with the highest numbers, are probably going to be the ones that we might be most interested in. So in this case, I am going to label everything above the 75th percentile. So in this case, we're finding the 75th percentile in our data. I covered this in our last introduction to R programming class, the if-else statement. So if you need help with this, the videos will be up soon, and all of our materials like the PowerPoint are already up. So in this case, I am going, when the state prescribing rate, overdose rate, is over 75th percentile, I am going to set the value as the state abbreviation. And if it's below the 75th percentile, I am putting a blank value here. So that's all that's going to do. So I basically added a label variable. I call it label include in our data set now. So I'm going to open this, state prescribing 2017. So this is the wrong one. So, oh goodness. I don't think this one might have been run. So if we were going to do this programmatically, so we have our labels. So this is an easier way. It might be an easier way to do this. So we have our data set here, state. We're printing. State label include. So it's blank for all of these values because it's not in above the 75th percentile. So we have that new label variable. That's all I'm going to add here. And geom text repel. So if you can use geom text for this particular use case. I would not recommend doing that. If you change this to geom text, our labels will be crowded together and they'll be on top of one another. Geom text repel basically automatically formats your labels so that they are not on top of one another. So all we're doing here is we have our geom text repel. We have to set an aesthetic here, just like we did up at the top. And we put label equals our label include variable that we created here. And we want to make the size 3. And that you will have to play with because it's not a specific value. So I created this and I need to actually print it. So to print it, we put it here. We're going to rerun this code chunk. So now you'll see here that we have labels for our 75th percentile here. So that gives us information about our most extreme states, those with the highest overdose rates. So the question that I got asked was, how do you add labels? You add them that way. You would use geom text as well. Say you wanted to add a text to the top of a bar chart, you would do something very similar to this for the bar chart. You would create a label and then or use your actual values, although they will not be rounded unless you round them correctly, and it will create that label for you. So in this case, I have the results down here. So that is ggplot. Those are very basic ways that you can do things. But if you go to, this is the no solutions part, run all the code above this class exercise, just so all your data will be in there. I am asking you to do one on your own. So in this case, we're going to do a line graph. So you'll probably, when you're doing this exercise, you'll want to go up to the final line graph that we created. And we would want to go to the top. And you will want to use this as a model for what you're creating here. So use this as your model. It will use the same type of syntax, and try to do it yourself is what we are going to have you do here. So we have our class exercise. The first thing, as I said, create a data set finding the mean across states by year and by drug type for the overdose rate. So we will use this state, overdoses, heroin, this value here. So we will, again, find the mean across states by year and drug type. So you are going to be creating a very similar graph to the one that I had on my our Shiny app. So we will create that by year variable, and then we will use as our other grouping variable drug type. So it'll be heroin versus opioids, because they are both considered opioid types. And then we'll be finding the mean of our overdose rate. So then create a line graph showing the year on the x-axis and the overdose rate on the y-axis. You will create a grouping variable for the drug, so heroin versus opioids, and try to do all the different like set the labels, set the put labels on your plot, change the size of your text, change the theme just as we did above, and then we can go over at the end. I will show you in a step-by-step fashion how that was done, exactly how that was done. So feel free, go and try to do this yourself. I will stay on the line. If you run into any problems, please ask questions. If you need to log off, please go ahead and do so. And then at the end, once I give you a couple minutes to try to do this yourself, I'm going to go over the final result. Although, if you want to do this later, the result, both of them are on our on the shared drive up here. So